This video is on squares and square roots and how we deal with radicals. So as a review, we're going to start with the idea of n squared. When you see this, that means n squared, not 2 times n. The word n squared, or the concept of that, comes from the idea that if you had a square and its sides were a certain length long, how would you find the area? Side times side, okay? So 6 squared is 6 times 6, or 36. Now, any number can be squared. A decimal can be squared, a fraction can be squared, or an integer can be squared. All you do when you square it is multiply it times itself. So in this case, 3.56 squared would be the same as you taking a piece of paper or a calculator and multiplying 3.56 times 3.56. Now, one important thing to remember is the order of operations with squaring. So negative 3 in parentheses squared tells you to take negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Okay, that makes sense. But if I just saw negative 3 squared, order of operations would tell me that first thing I have to do is exponents. So I would do 3 squared and get 9, then I would put the negative on it. So the negative of 3 squared is negative 1 times 3 times 3, or negative 9. So you need to pay attention to where those parentheses are and make sure you're using parentheses if what you mean is this and not this. Okay, the square root is the opposite of a square. It's the inverse operation and it undoes the squaring. It looks like that, okay? And what we're really saying is, what number did I square to get 36? And we know that the answer to that would be 6. But there's some important concept to remember is that it might have been negative 6, because negative 6 times negative 6 is also 36. So a lot of times what you'll see when you see an answer, the square root of 36, you'll see this little plus or minus 6 means, the 6 notation. And what that means is you might have a 6, you might have a negative 6, and you don't know necessarily. We see that a lot with quadratic equations. Oops, got this stuck there. Okay, now a perfect square, as a reminder, simply means that any number whose square root was an integer. Okay, so before we tried where we squared a decimal, we might square a fraction. Those do not result in perfect squares. Perfect squares are 9, because it started out as 3 squared. 16 is 4 squared. 25 is 5 squared. 36 is 6 squared, and so on. Okay, those are perfect squares. Perfect squares will always result in an integer. However, 40 is not a perfect square, because I don't have a number like 6 times 6, well that gives me 36. 7 times 7, 49. Uh-oh, there is no number, the integer, that I can multiply times itself to get 40. So 40 will not be a perfect square. Its square root will be a radical. And you can remember that when we solved radicals before, what we did was we took that 40 and broke it into pieces to see if we had any perfect squares inside of it. So we factor it down and we get 10 and 4, and then I factored to 2 and 2. Uh-oh, 2 times 2, that's a perfect square, and it comes out. But then I'm left over with the factors of 5 and 2. 5 and 2, that's not going to make a perfect square, that's 10. So I put them back together in multiplication, and my final answer for the square root of 40 is 2 times the square root of 10. You'll hear students also say 2 radical 10, and it does not matter. Now, the important thing to remember is this is an exact value. If I put the square root of 40 in my calculator, I will get a decimal value that's rounded, so it's not considered an exact value. It's okay for some operations, and they'll tell you use a calculator to find it, and that's fine. But when they say find the exact value, they mean you have to keep that in a radical form unless it's a perfect square. Okay? So let's talk about a little bit more about those estimations. Okay, to estimate the square root of 85. Okay, this is an estimation, so I know I don't have to leave it in radical form. I'm going to be using a decimal of some kind. So the first thing I do is I say, what's perfect squares is it in between? And I see 85, and I know that 81 is a perfect square of 9, and 100 is a perfect square of 10. So it's between 9 and 10. I know that my answer will be between 9 and 10. But where is it? How far is it? I've sort of picture a number line here. How far along the number line is 85 compared to 81 and 100? So to help me visualize it, I sort of put a spot here where 85 would be. So we can see it's much closer to the 81 side than it is the 100 side, isn't it? So what I do is I say, how many spaces are there between 81 and 100? So I did 100 minus 81 and I got 19 spaces. So there's 19 spaces. And 85 is only 4 spaces along there, right? 82, 83, 84, 85. So it only went 4 spaces out of the 19 spaces. So I wrote that down, 4 out of the 19. Now, this asked me for an estimate, not an actual number. So in my head, I kind of rounded that up to 4 over 20. Why would I do that? Because if I can get that to a 10, then I have tenths, and that's a decimal. So 4 over 20 would be 2 over 10, which is 2 tenths. So I decided that my estimate would be 9 plus that 0.2, or 9.2. And I could test that by multiplying 9.2 times 9.2, and I should get very close to 85. So when you need to find an estimate, you're going to bracket it between those two numbers and then sort of break it down a little bit more. Obviously, if this was halfway between, I would call it 9.5, but it wasn't, so we went through that process. Okay, so we're going to do a couple of practice problems. So what I want you to do is take a look at this and pause it, and then I'm going to go through this with you in just a minute. Okay, to estimate the square root of 42, first I find the perfect squares that are near it. And I decide that 36 and 49 are the two perfect squares near it. So that is, oh, where's my marker? That is 6 squared, and this one is 7 squared. And I'm going to put my 42 in here somewhere, right? That's the number I'm looking for. So next we're going to say, how far is it from 36 to 49? Well, I'm just going to subtract 49 minus 36. 9 minus 6 is 3. So it's 13 spaces. Okay? Now, how many of those spaces did I have to go to get to 42? 42 minus 36 is 6. 6 over 13. Now, to me, 6 over 13 is very close to 6 over 12, right? It's almost the same number. 6 over 12 is a half. So what I'm going to estimate is that it was started at the 6 and a half. This is my estimate for the square root of 42. So if you got something that was either 6.5 or maybe you went to 2 decimal places, 6.4 something, then that would be a correct estimate. Okay? If you did not, you need to go back on the video and watch through again how we use those steps so that you can do that. Now let's talk about finding the exact square root. Remember, that estimate we found and the number you put in your calculator both are rounded estimates. They're not the exact value. The exact value will be an integer or a radical. So 42 was not a perfect square, so we know it's not going to be an integer, it's going to be a radical. So we're going to break that into its factors, and I decide, well, 42 is an even number, so I pulled out 2 and 21, and I know 7 and 3 go into 21, so these are my factors. I don't have any duplicates here. I don't have any doubles that would tell me that I can bring one out. So I put them all back together again. Square root of 42 is the simplest form of the square root of 42. It can't be simplified any more than that, okay?